Have you ever stopped to think about why we investigate accidents? Do it now. Just stop for a moment and one sentence say why it's worthwhile to investigate an accident. I can pretty much guarantee that if you're like most people, you came up with one of two reasons. The first is that we investigate in order to explain what happened. The second is that we investigate in order to learn and improve safety. What I'm going to be doing in the next couple of minutes is just explaining why these two things, explaining and learning, are in fact quite different and usually contradictory activities. What does it mean in order to learn from an accident? What could we, in concept at least, learn? First thing is that we could learn something brand new about safety. We could actually increase our safety knowledge. Now, this implies a fair degree of humility. It implies that we don't already know what safe should be, what safe looks like, and that we're actually looking ourselves to find out what safety is. There are surprisingly few accident investigations throughout history that can stake a claim to genuinely finding out something new about safety. More likely, what we're going to find out is something new about our own organisation. So this means that there's a gap between what we think is going on and what's actually going on, and we're going to be doing something to close that gap in our knowledge, find out something new that we didn't already know about how things are. Third thing that we could find out, and this is unfortunately the most common, is we just find out what happened. Now, finding out what happened in the past is not directly learning at all. It's only useful if it somehow changes us. We don't say that someone has learned something unless they're able to demonstrate that learning, unless they have in fact some new skill or new knowledge that they can apply in future situations. So this leads to the first law of instant investigation. An investigation is only successful if it increases the knowledge of the investigator, and it needs to do that in a way that is generalizable beyond the particular circumstances. So increasing your knowledge about what happened doesn't matter. What matters is, have you increased your knowledge in a way that you can take on to future situations? Let me explain what I mean by that. Have a look at this graph and have a think, what does it show? Now you're probably thinking, Drew, this is a trick question, right? Yeah, but the point is, what type of trick question is it? What does this graph show? First thing it could be is it could be some sort of linear trend. We could be looking at some improvement in safety over time. And if you extrapolate from this graph, you'll see that give it another few days and we're going to start resurrecting dead people. Because if the linear trend continues, we're actually going to have a negative injury rate. Second thing you could be seeing is in fact the symptoms of two different interventions. We could see reduction once, followed by a steady state, followed by a reduction again. Third thing you could be looking at is just noise. Could be that in fact the accident rate is going up and down all over the place and it just happens to seem to form a graph. Or the final explanation is it could be fraudulent reporting. Could be that yes, it is linear, but it's only linear because it's been rigged. Now, the real underlying question here is which one of these things is it? Is it fraudulent reporting? Is it just noise? Is it two different interventions? Is it a linear trend? And you can't tell just by looking at the data. In fact, even if I gave you a story, that's not going to help. Because I could tell you a full story about why you should expect this to be a linear trend. I could say that we've been implementing a safety culture program, and you don't expect safety culture to achieve step change. What you expect is as staff in the organisation gradually turn over time, with a constantly reinforced safety culture program, you expect gradually the culture to improve. So that's what we're seeing here, and of course we don't expect it to go to zero, we're expecting it to level off any day now. I could tell you an equal story about how we put in place a new set of guards for all of our machines. Only when we put them in place, we realised that in fact they interfered with operations and needed to be adjusted with some new processes and some changes to the design in order for them to work effectively. So we had one intervention, improved safety but not as much as we thought. New intervention, that got safety down, not to zero, but down to a much lower level. I could give you a talk about statistics. I could give you a talk about Poisson distribution, statistical significance, and the need to actually test not whether your safety data is going up or down, but whether that change is in fact significant. And at the end of that talk, I show you this graph about how noise can appear to be significant even when it's not. I could give you a slightly different talk, which talks about what's the likelihood, given the level of noise we have in safety data, that you would ever have 4 data points in a row monotonically decreasing, and make the argument that any time you saw safety appearing to constantly go down like that, it is far, far more likely that it is fraudulent data than that it is in fact real improvement data. Now, having told you those stories, you still don't know what it is. All of those stories are just reconstructions of the past based on the same underlying data, which was insufficient to tell you what's going on. So which explanation you choose to believe is really as much about your belief in which story is acceptable and your relationship with me as the storyteller, rather than something fundamental or scientific. A good explanation for something is a social construct. It's not a scientific thing. Scientific explanations come in their predictive power, in their ability to say not what has happened in the past, but to make firm predictions about what will happen in the future. So take a look at this picture. Now notice I was honest before I was giving you a trick problem. This is not a trick problem. These are 2 guys in a roof, no safety equipment except for these high-vis vests. I'm not going to suddenly zoom out the picture and show you that they are in fact standing with nets below them. I'm not going to zoom in and twist the picture to show that they're in fact standing on level ground. This is of course a dangerous situation. But I want you to think about, how do you know that it's dangerous? What are you doing in order to think that this is dangerous and something else is not? What you're doing is you're applying patterns. You're applying patterns of things that you expect to see there but don't. You're saying, well, when someone is working at heights, I expect to see edge protection, I expect to see fall protection, and I don't. You're applying patterns of danger. You're saying that when I see people up off the ground, that's automatically more dangerous than when I see them down on the ground. When I see the roof tilted, I'm seeing that as more dangerous than when the roof's flat. When I see all these discolorations, I'm thinking that's a pattern that could mean that some bits are stronger than other bits. Maybe some of these are bits that they could fall through. And this works not just with real pictures, but let's go on to a hypothetical situation. Now, whether you think that this is safe or not depends on which patterns you choose to match. You could match the patterns which say, well, rockets are supposed to have control systems, this one doesn't. You could match the pattern that says, well, rockets are inherently dangerous. You could match the pattern that says, well, Wile E. Coyote always ends up getting himself hurt. Or alternatively, you could match the pattern that says no matter how hurt he gets, he always gets through it okay. So you could choose to say that this is dangerous or not dangerous, but your choice of doing so is about matching patterns that you already hold. And this is the problem. Explanations don't create new knowledge. What they do is that they apply existing knowledge. What you view as safe or unsafe are deviations from what you see as normal, or patterns that you recognize as already dangerous.